Well, good afternoon. Thanks, everyone. We have a special presentation today from astronomer Dean Regas to continue our celebration of International Dark Sky Week. Hi, Dean.
Hello, how are you doing? Hello, everybody out there. Thanks for having me.
We are so excited that you could join us. And so again, for those of you tuning in, comment below. We want to know where you guys are live watching this from. And if you know of anyone who is also fascinated by space, astronomy, invite them too, tag them so they can also join us. So for those of you that don't know, Dean has been an astronomer with Cincinnati Observatory for 20 years and is a renowned educator, author, and expert in observational astronomy. So you may have seen him during his co-hosting days on the PBS program Stargazers, or heard him on his recent astronomy podcast, Looking Up. And Dean, I know you have been author of a couple books. Which books are those that you want to share?
So my first book is called Facts from Space. It has almost 1,000 facts in it from around the universe. And then my latest books are 100 Things to See in the Night Sky and 100 Things to See in the Southern Hemisphere Sky. So I have another one coming out here in June too on stargazing. So it's been great to add that to the mix.
Wow. So coming out in June on, is it stargazing specifically from certain areas of the country, or what can we expect with that?
Yeah, so it's kind of a follow-up to my 100 Things to See in the Night Sky. It's called 100 Things to See in the Night Sky Expanded Edition with more charts, more pictures, more things to grab your eyes with, and some updates on some new objects to look for as well.
Well, I'm excited. I can't wait to see that. That will be a great read, especially as we're getting into more of this stargazing and, backyard star parties. And I think that will be a great resource for people. So for those of you guys just joining, we're sitting down today with astronomer Dean Regas to do a tour of the universe. So he's also going to be able to answer a lot of your space questions live. I know I have a couple queued up that I can't wait to discuss with you. So as we're going through, please feel free to comment with any questions you have for Dean. But at this point, I'm going to turn it over to you, Dean.
All right. Well, great. Well, thanks so much for setting this up, Alyssa. This has been a lot of fun chatting with you and getting this all together. Let's see. I'm going to go to share my screen here, and we're going to take a look at this. And let's see here. Hopefully this is all working. Slowly.
It looks good.
Well, hold on. It's still taking its time for some reason. There we go. All right. So yes, I'm from the Cincinnati Observatory. This is the place where I work here in Cincinnati it's a historic observatory with two very old telescopes. One of the telescopes is, well, it's pretty much the oldest one in the United States, made in 1845. And so this is the older of the two telescopes. So it just had its 175th birthday, just this April 14th. And so it's amazing to work with this old telescope, 16 feet long, made out of wood and brass, and it's still in great working condition. And that's our old telescope. This is our new telescope. That's only 116 years old. It's a baby compared to the other one. Well, it's a pretty big baby. It's 22 feet long, 16 inches in diameter. And so both our telescopes are in working order. And we'd love to have you come over. If you're ever in the Cincinnati area, stop on by, say Dean sent you, and come on over and look through the telescopes. And we'll be able to show you the planets this summer and lots and lots of stars and the moon coming up. Like Alyssa said, I've been doing this for a while. This is my 20th year of being an astronomer. And this is my first book here called Facts from Space that I was mentioning earlier. And then the other book is 100 Things to See in the Night Sky, and you can check those out. It's a great introduction to the sky for all ages. Really, the Facts from Space book was supposed to be for adults, but it seems like kids really love it too. I think like kids and adults are like at the same level with their fascination with space. So you could pick those up. And then I also have a podcast called Looking Up. So if you're into podcasts, this is a podcast that kind of starts from the basics and talks about what's in the news with astronomy. And right now we have our interview with William Shatner on the podcast. So you can look, and now you got to meet him in person whoa, man, it was quite the anecdote with that. But so as you can tell, this is something I'm really into. I'm really into outer space. I really like talking about space and thinking about space. And I've had a great connection with the Grand Canyon over the last several years too, that I've come there for the Grand Canyon Star Party every June for the last 4 years. And it's just such an amazing place, such an amazing location, and the dark skies there are just incredible. I mean, as part of my job, it's my vacations is to seek out dark skies since I live in a city. And so coming out to Arizona and coming out to the Grand Canyon, it's just one of the joys that I have every year. And so I'm it's just an amazing location, and so boy, it's just got a really good spot in my heart. The Grand Canyon does. And so the talk that I usually give there is one I'm kind of going to give you here today. It's a little modified version of it. And the talk that I'm going to give you here is called The Tour of the Universe. And wouldn't you know it, my PowerPoint stopped. Wasn't that interesting?
Well, while you cue that up, for those of you guys, we'd love to see a thumbs up in the comments if you've seen the dark skies over Grand Canyon. They are so magnificent, and I can see why it attracts a lot of astronomers. I know I truly adore them.
Oh, most definitely. Well, so let's see. Boy, of course, this has to stop right at this very moment. Let's back it up here a little bit, and we can see both of us at least for a while. And so what we'll do is I'm going to switch to another program. Hopefully this will work smoothly. It all went great in rehearsal, didn't it?
I know, I feel like I'm 2 for 2 this week with fantastic rehearsals, and then when we come live, we just love to troubleshoot all of our technology.
That's right. Okay, well, so do you see a space view out there?
I see a space view. I think we got it set up.
Excellent, excellent. So now what I'm going to be showing you, this is a program called Mitaka. It's spelled M-I-T-A-K-A. It's a free program, free to download from the internet, and it can basically show you the entire universe. Everything that there is out in space, all the stars, all the planets, all the galaxies, pretty much everything that we have ever seen in telescopes, it's on this map. And it's great because it's free and you can just manipulate, you can go anywhere you want in space and anywhere in time. And so we're going to start right here on the Earth, and we're going to leave the Earth behind. So we're going to blast off of the Earth, and here we go, leaving the Earth behind. And as we lift off of the Earth, we come up above Japan. Well, that's because it's a Japanese program. So we want to be centered over that. And then we can go up all the way to see the entire Earth there. And so there we have us. And what we can also do is move around and look at different parts of the sky. So here we can see different parts of the sky, different parts of the globe. And so I can click and drag and move anywhere around to see what's going on in Africa and Europe and all the blue spots of all the ocean. And then the sun's light is hitting one side of the Earth and the other side is in darkness. So there's the sun over there. And I can make a giant eclipse. There we go. So the other part about this is really great. I can go anywhere I want, but I can make it any time. So I can speed our time forward and go forward in time and make the Earth spin. And so we can see the Earth rotating once every day. When we rotate towards the sun, it's daytime. When we rotate away from the sun, it's nighttime. Well, now let's back it up here. Let's leave our Earth behind. And we're going to go off of the Earth, and then we're going to make some stops along the way. We're going to make these big leaps through the whole universe. And so when we start with this, we're going to go out to our nearest neighbor in space. So I'll pause for a moment for you to think and answer the question, what is the nearest neighbor in space most of the time? Okay, I won't pause too long. We have a long way to go. And there it is. There is the moon. So this is the Earth-Moon distance there. If the Earth was this little, and the moon would be that little, that's how far apart the two of them would be. So the moon's a little speck there, and this is the moon's pathway around the Earth, its orbit. And so I can get our time moving a little bit faster here. We're going to go 4 hours at a time, and we can watch the moon revolve around the Earth. There we go. And so it takes the moon about 1 month to go around the Earth. Wait, what did I say?
I was just thinking that same thing. I'm like, I think I need you to repeat that word.
It takes 1 month for the moon to go around the Earth. Now, okay, so this is a term I kind of made up, kind of. So it takes about 29 and a half days to go through the whole cycle of moon phases. So I call it a month. What do you think? Catchy? Not too catchy?
I mean, it stuck with me. I do feel like if you created your own dictionary of clever astronomy words, that would definitely be in there.
All right, I'm working on it. I'm working on it. And the fifth graders love it. I mean, I do a fifth grade presentation. Fifth graders, this is like the best joke ever. A month. So, anyways, share it around. See what you think. See what you think. But it takes about a month for this to go through the whole cycle. Now, this is the farthest any human has gone. Neil Armstrong, Buzz Aldrin, the other astronauts, it took them 3 days to fly from there to there. And they spent a few days on the moon, around the moon, and 3 days to fly back. So it was about an 8.5 day trip to the moon and back. So I don't know if anybody would want to go on that trip now. Any takers out there that would like to go on an 8.5 day trip to the moon and back. And I know everybody's kind of got cabin fever now. Imagine being in a spacecraft for 8.5 days. Well, I guess we could probably do that, stay on our head now. But so what we want to do next is we want to go to the next level. And so I'm going to leave the Earth and the Moon system behind. And we're going to go out among the planets. And so now the moon's orbit is going to be so small and the scale will disappear. And we can start to see the curve of the Earth's orbit around the sun. And our nearer planets of Venus, Mercury, and Mars out here. So these are our inner planets and the sun. Now I can center on the sun to get this in the center there. And now we've got that all set up. And so we can back up and see our inner planets, Mercury, Venus, Earth, and Mars. Now we have one extra circle that's red. This is called it's a distance marker, 1 astronomical unit. That's the average distance from the Earth to the sun. So that's just showing us this distance here. Now, and I can move our time forward a little bit faster, and we can watch all the planets circle around the sun. So here they go. And they all go around the sun the same direction, but not the same speed. So you can see Mercury's fastest, Venus second, Earth third, Mars fourth. That seems like a pattern to me. And the pattern is the closer you are to the sun, the faster you go. So a year on Mercury, the time it takes to go around the sun, is only 88 days versus on Earth, which is 365 days. So if it's always fun to try to compute how old you are on other planets, how many birthdays you have on Mercury. And again, this is another great joke so you can give to elementary kids. You say, oh, if you're 10 on Earth, on Mercury, you'd be 40 years old. And they're always like, oh my gosh, that's so old. Oh my God, that's terrible. Oh, I'd be ancient. And then if you're on Mars, if you're 10 on Earth, you'd only be 6 on Mars. And they think that's hilarious because they think being 6 is hilarious or something like that. So anyway, just little tips you can talk to kids about and get them excited. Now, if we want to see the closest planet to us, that would be Venus, but Venus would not be a very good place to go visit us. So Mars is our best destination to send humans. Venus would just be too hot. It's about 900 degrees on the whole planet. You just melt into a pile of goop pretty fast. So Mars, well, you got some problems there. There's not enough oxygen. The temperature is very low. Air pressure is very low, but we can deal with that. We can bring all that stuff with us. The problem is the trip from there to there. It looks very close, but on this scale, it would take 7 months to make that trip. 7 months to go from there to there. I know it only looks like a few inches away, but in reality, we're talking millions and millions of miles. And then once you get to Mars, well, you gotta wait until Earth comes back around because 7 months later, you're on the other side of the other side of the sun. So you have to wait on Mars 1 year for the Earth to catch up. Then you fly 7 months to get back home. So you're gone over 2 years if you're going to go to Mars. So for everybody that volunteered that would make the 8-day trip to the moon, how many volunteers do we still have to do the 26-month trip to Mars? I don't know.
Raise your hands in the comments. We'd love to know who would want to take that time out right now.
I know. Boy, I'm feeling trapped right now. I don't know about 26 months in a little spacecraft, a little planet, and I don't know. I'm having trouble going to the grocery store now. I mean, think if you have to bring everything with you. That would be tough. But I think this is something we are going to do, and it's not going to be too far from now. I think that we're going to start sending people to Mars in maybe 15, 20 years time, something like that. And so it's just a matter of getting a lot of details worked out. But going to Mars is like a whole different ballgame than going to the moon. It is quite a journey. Well, let's back up here a little bit farther because we haven't really gotten very far. We're out to Mars, and then between Mars and Jupiter, we have lots and lots of rocks that are going around the sun. These are all asteroids. And so these are a lot of the asteroids that have been charted very relatively recently. And so they're all going around the sun also. Now we've been looking at this from the top, but if we look at it from the side, we get a different perspective on the solar system. We get to see all the planets are kind of in the same plane in this flattened disk. And even a lot of the asteroids are in that plane also. There's only one really thing that's kind of going diagonally through this. And yeah, that's our friend Pluto, which we will talk about later. Do not worry, I will weigh in on Pluto. But let's back up a little bit more. We get to Jupiter, and we get to Saturn out here. And I'm going to center on Saturn just because this is my favorite planet. We can zoom in on it and come in a little closer. So as we zoom in on Saturn, we can see Saturn's moons. That's now up to 82 known moons around Saturn. And the inner moons here, like Titan and Dione and Enceladus. And then we got the beautiful rings. And this is one of those planets that is just unbelievable to see in a telescope. It just does not look real at all. It looks like somebody put a sticker on the end of the telescope. That's what people actually ask me. They say, Dean, wait, where's the sticker? You're fooling me. No, this is the real planet. This is what it really would look like with the rings and everything. Of course, it wouldn't have labels on it, but it would have the rings on it. It would still look like that. So the best time to see Saturn this year is late July, early August, and then even into September and October, you'll be able to see it in the evening sky through telescopes. So let's back up some more. And we're going to leave Saturn behind and then go out to the outer planets past Saturn. And that brings us to Uranus and Neptune. And so here is the bulk of our solar system. And each of these planets is so spread out, so far apart from each other. But now we get to the controversial part of the program today. And I think Alyssa was asking about this. Pluto is definitely a sore subject with a lot of people. Is that what you think? Is that what you hear from Arizona?
Well, being a Flagstaff local and a big fan of Lowell Observatory, we take a lot of pride when Pluto was discovered. And when I found out that you don't agree you don't think that it's a planet, my heart was broken. I'm not gonna lie.
Boy, I'm glad I'm 1,000 miles to the east of you guys and away from the slings and arrows. Yes, I'm going to go out and say something very controversial. I'm sorry for all the Flagstaff residents and Arizona in general. Pluto is not a planet.
Yes!
Sorry, Pluto is not a planet. Now, I did not come to this decision very easily. Trust me. I've had a lot of sleepless nights. I've been tortured by this thought for a long time, and I fully recognize Arizona and Flagstaff's right to own Pluto. It is yours. You found it, and the Lowell Observatory is one of my favorite places in all the world. And the Pluto telescope and everything, the history behind it, I love it. So this is why Pluto is not a planet to me, and that is because, well, it's not because it's small. That's no problem. It's not because it has a weird orbit. It does have a weird orbit. I will give it that. It's not because it switches places with Neptune. It doesn't help it, but it does get a little closer to the sun than Neptune. And what the problem was is all these other dots. If you see all these other dots out here, these are all the things that we've discovered since Pluto. And so like when we were kids, Pluto was a planet because it went around the sun. Here, I'll show you. It goes around the sun. We can move our time forward. It has to go 1 year at a time to go forward. Here it goes. And so when we were kids, this map was a lot simpler. Pluto went around the sun. Bingo, that's a planet to me. The tricky part came in the 90s and 2000s when they got better telescopes and they started recreating all the surveys that Lowell Observatory did with the better telescopes. And then they started finding these other objects. And we're now up to over 1,000 other objects that are out there. And a lot of them have the same orbits that Pluto has. Some are the same size, some are the same makeup, the composition. And so the astronomers had to make a decision. They had to say, okay, all right, if we're going to keep Pluto as a planet, what are we going to do with the other 1,000 things? And some people said, make them all planets. And there's a little bit of a problem with that. You make them all planets. How are the kindergartners going to memorize the 1,008 planets? It's too much. It's chaos. It's ridiculous. And if you're going to keep Pluto, you got to keep the other ones because they're going to feel bad too. So they decided to make a tough decision and put like things with like things. And Pluto resembles the other 1,000 things a lot more than it does the other planets. And I know that didn't convince one person in Arizona that Pluto should or should not be a planet. I'm only saying what happened to me, and I know it's like you want to turn this program off right now. I'm sorry. Please bear with me.
I do trust your education, and you are the expert here. I will probably always hold Pluto as a personal planet in my mind, but know that based off of what you showed here, which is absolutely incredible, you do have some good reasoning behind why it might not be a planet.
Wow! Oh my gosh, I have good reason. This is a breakthrough from. I've never heard an Arizona resident actually say that, but I'll take that as the supreme compliment. But you know, I still hold. I mean, I love Pluto because it was the oddball. It's such an interesting world that we sent a spacecraft out there, flew by there. It took 9.5 years to get there. The New Horizons spacecraft went by Pluto and took these great pictures. So there's only one other consolation I can have. If you think Pluto was, you love Pluto because it was unique and special, well, let me introduce you to Sedna. This is an object that goes around the sun. We found about 15 years ago, and it goes into orbit around the sun like this. Super far, almost 1,000 times farther away from the sun than the Earth. And to see it moving, I have to go 100 years at a time. And there it goes, slow when it's far away, and then fast when it's close.
So when you changed it to go to 100 years, so we did get a question about this too. So at the bottom, we're now theoretically looking at year 2000 or 25,190.
You are correct. It takes Sedna about 12,000 years to go around the sun one time. So I've gone around once or twice here. So we can predict in the future where these things are going to be based on how we've watched them. And so Sedna is a one-of-a-kind object that goes out that far from the sun and still circles around. So if you love Pluto, well, here's Sedna. Sedna will be your new Pluto. In fact, I think you should make t-shirts that say Sedna is the new Pluto. And then I love Arizona on the back and Flagstaff. That's what I'll have. But nope, okay, that didn't.
I'll be your first buyer. We'll try it. We'll run with it.
We'll just keep going, and hopefully people haven't tuned me out completely because we have so much more to go here. When we get past Sedna, then we get to the farthest reaches of our solar system, the things that go around the sun. This is the comets, where the long period comets live, that go in very long orbits around the sun. Some comets can go all the way out to 1 light year. That's the distance light travels in a year. So in miles, that's almost 6 trillion miles right there, from there to there. And so everything in this circle would be considered in the solar system. So all the planets, all the Plutos, all the Sednas, all the comets, asteroids, everything in here is in the solar system. And it's all being held together by our one star in the center, our sun. And so there's our sun in the center of the solar system. So now if we want to go to the next level, we need to go to the next sun and the next solar system. And that is quite a jump. We're going to go back out to 1 light year again. And to go up to the next star, we need to go a little bit farther, out to about 4.2, 4.3 light years away. And I'll bring it up to the top. It's called Alpha Centauri. That's our nearest star system to us right here. And it's not like our sun. Our sun, we have 1 star in our solar system. Alpha Centauri has 3 suns in its solar system, 2 yellow ones and 1 little red one that circles around the 2 yellow ones. So you'd have 3 suns in your sky if you lived around Alpha Centauri. Now, before you pack your bags and start heading for the triple sunset of Alpha Centauri, there's some problems. It is 25 trillion miles away. And so that means even with the fastest spacecraft we made, going at 50,000 miles an hour, we aim that at Alpha Centauri, you will not get there for 70,000 years. Yes, as the fifth graders react, I'd be dead. Yep, you would be dead. You would not make that trip. That is true. And this is the closest star to us, the closest star to our sun. So if we go a little farther, we can see the other stars that are out here that are even farther, like Sirius and Procyon and Altair and Vega and Capella. And now we're at 100 light years away. And we got to remember, this is all in 3 dimensions all around us. And we back up here some more. And we can get the other stars like Polaris and Spica and Canopus, the Pleiades, Antares, Deneb, Rigel, Betelgeuse. And here we are at the edge of the stars that we can see at night. All right, now I want to pause here for a second. And let's take a breath. We just made a big leap from the sun to all these stars. How's everybody feeling out there? Are you feeling big, mighty, and important?
I mean, I can only speak for myself, but my mind is blown right now. For those of you guys that are still tuning in live with us, we're sitting down with Dean Regas, and he is showing us this amazing platform, Mitaka, that is taking us light years away in our universe. You know, we've gotten a couple comments, and I think a funny one, which is somewhat relevant, there was a show Devs that was on, is, you know, we're kind of predicting the future right now, aren't we, with these, you know, patterns and planet predictions and where we're going.
Yeah, that's I watched that show too. It was very interesting. The ending and the premise was like this multiple universes idea. And yeah, with this we can predict into the future, thousands, hundreds of thousands of years where things are going to be based on the data we've had. And yeah, it is pretty incredible. And I know that this starts to get intimidating at the scale. You see all these stars out here. These are all the stars that you see at night. And you know, I didn't mention my themes for the program here, Alyssa. The theme number 1 is space is really big. So I think maybe people are starting to get this, but we still have not gone anywhere. We're just in our local stars. If we back up a little bit more, we can see that all the stars, the thousands and thousands of stars we see at night, are only one teeny tiny little section of one arm of our galaxy. And so there is our Milky Way galaxy. It's a flattened spiral of 300 billion stars, 300 billion suns, and our sun is that one. So this is our bigger structure. So we went from the Earth and the Moon to the solar system to our local stars, and now our entire galaxy of stars. So this is 300 billion stars. And so our sun, notice where we are. We're not in the center. We're out here on one of the edges, on one of the arms. That's probably a good thing, because in the center of our galaxy, we're going to zoom on into this. And we'll zoom on in. And through all the bright, bright stars here, we'll zoom on in and zoom on in. This is where something resides, a deep, dark, mysterious object of incredible density that warps the space and time around it. You fall in, you disappear forever. That is the black hole at the center of the galaxy. And so this is our artist rendition of what we think our black hole galaxy looks, or black hole looks like in the center of our galaxy, called Sagittarius A star. And so this is an object that's the mass of 4 million suns in one spot, crammed together, and the gravity is so intense, light can't get out, nothing can get out. And what happens inside there, nobody knows. All physics breaks down. We don't know if it sends you to a different universe, a different part of the universe. I'm a romantic, so I think you're there and you're crushed to dust. That's just me. That's what I think. I don't think you go anywhere else. But you know, that's the opposite of romantic. But anyway, whatever it is, but who knows? This is one of those things, and people are really fascinated by black holes, especially because of the mystery behind them. But the good news is there's no way that this is going to swallow us up. We're way too far away from any black holes for them to affect us. They don't have a big reach. The gravitational pull, gravity kind of dissipates pretty quickly over space. But we are watching these stars that are nearby it, and one of them that's going around it is exhibiting exact S2 right here is exhibiting the exact things that Einstein predicted. The way that it goes around the black hole, it kind of goes like this, so it makes a rosette pattern as it goes around. And one of these stars might fall into that black hole at some point too, which is fun to watch from afar, that's for sure. Well, let's take you out of the galaxy. It's going to get bright here real quick. So watch your eyes, all those billions of stars, or should I say billions and billions of stars. There it is.
So as you're backing out, we actually just got a question from Jeanette. So is the measurement of a galaxy based solely on distance or physical attributes?
Yeah, so there's a galaxy it's kind of it's a loose term in a lot of ways. A galaxy is just a whole mess of stars with a center of gravity, a center of mass. So when we look at our Milky Way galaxy, we say, okay, these are all stars that are gravitationally bound to the center of this. So they're all together. Around us are little dwarf galaxies like the Small Magellanic Cloud, Large Magellanic Cloud, and other dwarf galaxies. But there's also some things within our galaxy that are pretty big, like M13 and Omega Centauri. There's so many stars in this. And the Omega Centauri is this thing that you can just barely see from the Grand Canyon. It's just above the southern horizon. It's just this glob of millions of stars in one place. So it's almost been called a pseudo galaxy, but it's within our galaxy. But you get all different shapes, you get all different sizes, and our Milky Way is a pretty big galaxy as things go. But are we ready for the next jump? What do you think?
I think so.
The next jump will be to the next big galaxy, which is the Andromeda Galaxy. And that's down here. And the Andromeda Galaxy is the farthest thing you can see with the naked eye. You just barely make this out from the dark skies in the Grand Canyon, just with the naked eye. And this is 1 trillion stars. 1 trillion stars in one place. And you can barely see it with the naked eye. That's how far away this galaxy is. Think of our sun multiplied by 1 trillion, and you can't find it. That's just space is big. That's all I could say. Space is big. So then there's another galaxy out here called Triangulum. It's just got 40 billion stars, so that's barely worth talking about. So let's skip over that one. But Triangulum, Andromeda, and the Milky Way are the 3 big galaxies in the neighborhood, what we call the local group. So here we are in the local group. All right, let's take a little deep breath. We've gone from the Earth to the Moon, to the planets, to Pluto, to Sedna, comets, stars, the galaxy, and the local group. We got one more step, and this is the big, big one. The final step to show you the entire universe. Are you ready?
Ready.
Okay, because at this point in the scale, every dot in the background is not a star. Every dot is a galaxy of stars. And this program has them all charted. All the galaxies that we have seen are all charted. These are not just arbitrary dots. That is an actual galaxy with a name, NGC 3319. Not a very creative name, but it has a name. This is UGC 9242. Again, not very creative. But all of these are actual objects that have been observed and photographed. And so when I back up, let's see how many galaxies we have in the universe. Hold on to your seats.
Holy smokes.
And that is the universe. Whew. Yeah, gives me chills every time I do that. And so now, okay, you gotta, let's get back to, okay, let's snap out of it. No, how's this, wait a second, how do we know all this? How do we figure this all out? And this is what's incredible about telescopes and astronomers is they can figure this all out. Remember, we're just in the Earth there, somewhere in the center there, and we can map out this entire thing. This outer edge, this is this colorful material. This isn't what it really looks like. It's just the way we represent the heat. This is the leftover heat called the cosmic microwave background. This is the leftover heat from the creation of the universe. And so this is the farthest stuff that we can detect. Outside of this bubble, nobody knows. Is there another universe? Nobody knows. Are there multiple universes? Nobody knows. But this is our universe. This is everything that we can detect in there. And if we are just getting started, because in this bubble, there's some holes in our map. As we look in here a little closer, you can actually see the galaxies are in a weird shape. They're in like a butterfly shape. And that's because all the stars in our galaxy are getting in our way. We can't see through those stars. It's like looking through a forest with trees and you can't see through it. The other holes in the map are because they ran out of money. So they're gonna get some more money. They'll figure out how to look through the stars in the galaxy and then we'll map the rest of it. And if this is a sample of the whole thing, we're looking at 2 trillion galaxies in our universe, each with billions and billions of stars. So, yeah, well, I'm making everybody feel really small today. That was actually goal number 2. Goal number 1 is space is really big. Goal number 2 is you are really small. Sorry about that. I should have led with that one.
It does kind of go against, you know, us being with Green Canyon Conservancy. We tell everyone to be a part of something grand, and this is way beyond that. You know, Jim just commented, now that's a lot of galaxies. I have to agree.
That's a lot of galaxies. 2 trillion galaxies. I like that. That's an understand. That could be another T-shirt. Pluto. Man, that's a lot of galaxies.
We can have a whole line of merchandise just from this presentation today.
Yeah, and I just like I like writing out the numbers. I like writing out the number 2 trillion, and I like writing out if you want to do some real fun math, multiply 2 trillion times 300 billion. That's about how many stars are in each galaxy, and then see what that number looks like. That's a lot of fun. That tells you how many stars there are, and then that kind of gives us an idea of that there should be lots of planets out there, and that I'm going to ask one of the questions that people do ask a lot when they see this program is, are we alone in the universe? And now this is where I go away from my scientific answer. My scientific answer is, well, we don't know. We've never seen any aliens. We've never seen UFOs. I've never seen UFO. In 20 years of watching the sky, I've never seen anything, never heard any aliens. So scientifically, there is no evidence we have aliens. So I'll push that aside and then say what I really believe is, of course there's aliens out there. There's gotta be. How can there not be aliens? We got 2 trillion galaxies. We got all these stars. If this is our universe and we're the only ones here, man, what a waste of space. I mean, you gotta put something else in there. There's gotta be. But that's me taking my scientific hat off. So I'll put my scientific hat back on and say, nope, there's no aliens. But, you know, come on. We're gonna find them. We're gonna find them. We're pretty good at this. We'll figure it out. So
well, I think we can all appreciate, you know, when you can switch between the scientific and the personal hats, because I'm sure everyone wants to know that question. And it's probably something you get regularly, even from the 5th graders all the way up to the adults of the world.
That's right. So, well, we're at the edge of the universe. Do we have any other deep questions while we're out here before I take you back home?
We do. You know, we've gotten a couple questions come in. And this one might be definitely more relative to when we go back home, but Trish had asked, was the meteor shower visible this week?
Oh yeah, we had a meteor shower called the Lyrid meteor shower that was visible on, the peak was Wednesday morning, but it still can be visible a couple days before and after, so you still have a chance to see some meteors the next couple nights. And what a meteor shower is when the Earth runs into the leftover parts of a comet. Usually it's a comet, and in this case it's a comet called Comet Thatcher, and it left part of its tail behind, and so we run into this every year, so we can predict it. Every April 22nd or so, you have the Lyrid meteor shower. Now, This one's not one of the best of the year. Usually it's the Perseids in August, or the Leonids in November, and the Geminids in December are starting to get good too. But so this one's pretty good. The reports I heard, we had a clear night here, and people said they saw maybe about 10 an hour streaking across the sky. So it does, you got to be patient. But if you're in a darker sky, like in Flagstaff and the Grand Canyon, you're going to see a lot more than I would see here in Cincinnati. So the peak is over, but there's still a chance to see them. And we're really, in this time, we're really encouraging people to get outside and see the stars and share with your friends and family and fellow quarantinees, or whatever you call yourselves, as whoever you're quarantined with, and kick back and watch the sky, because it's real easy to watch a meteor shower because you don't need a telescope or anything. You just kind of sit back and relax.
Wow. So this next question before we zoom back and start to wrap up is from Noah. And so he was wondering, with the viewpoint now of this entire solar system, with us at the center, and is it limited to how far the telescopes can see to the 12.8 billion light years away?
So yeah, so it's what's the limit to what we can see, basically?
Yeah.
So we're not terribly limited by the size. The telescopes that we have can see as far as we want to see. This is where we get into some deep stuff. Are you ready to have some deep thoughts here? I know everybody out in Mountain Standard Time, it's probably lunchtime. I don't know if you can take this on an empty stomach, but I'm going to do it anyway. So this is the deep part, is that this edge of the universe isn't really the edge of the universe. This is just what it looks like from our perspective. The farther out we look in space, the farther back in time we look. It takes time for light to go from one place to another. And so when we look at the sun, that's actually not the sun. That's where the sun was 8 minutes ago. It takes the light from the sun 8 minutes to go from there to us. So we see it 8 minutes later. When we look at stars, that's where they were years ago. When we look at galaxies, that's where they were millions of years ago. And when we look at the cosmic background radiation, that's where it was 13.8 billion years ago. And we think the universe, all the evidence is pointing to the universe being created about 13.8 billion years ago. And so we can't see past this bubble because that was before time existed. Yeah, I don't know. Some people, their heads explode. Some people, they don't. I don't know. But so it's like a wall that we won't be able to look past this because there was no universe back then. Other people are saying, give us 1,000 years, we'll be able to figure it out. I don't know. It's a tough one to say, but it's deep, man. That's all I'm saying. It's deep.
And that perfectly summed up, because another question was from Jeanette, which is asking, is it the edge? Because that's just as far as we've gotten. But you did a great job at incorporating that in there too. Is that's just what is available to be seen right now.
That's right. That's right. And the universe is expanding. And what's it expanding into? I don't know. It's one of those things. It's like we are limited. We can't picture infinity. This is our best picture of what infinity looks like, and even this is lacking in a lot of ways. So, what do you say? You want to fly back home? Is everybody getting cold out here in the farthest reaches of the edge of the universe?
I think it's time to come home.
It's time to come home. So I'm going to target the Earth. We'll center on the Earth, and I'm going to fly you home really fast. And one little thing is, I know that there's no sound in outer space, but I'm going to use sound effects. So here we go. And we're back to the Earth. And let's zoom on into the moon. Here's the moon. Here's the moon. And let's see, we got you to the edge of the universe and back. And if you look at the bottom, it is only November 24th, 39,890. So, whoa, I went a little over on my time here today. I'm sorry about that. Your family's been worried about you, but Earth's still there. That's a good sign. So, yes. Yeah, I hope you enjoyed this tour of the universe and everything, and seeing what all's out there. We could, let's see, have some time for a few more questions or anything like that, I can bring this up to our kind of more full screen, I think. Let's see if this will work. There we go. Whew,
Yeah, we've
man,
been
I'm
able.
exhausted. I don't know about you, but I'm tired. That was a lot.
You know, I don't think I could have made that journey home without the sound effects. So it really would have been a lot more boring. No, I just, this was fantastic, Dean. I mean, this was a real eye opener. We do, if anyone else has any questions, feel free to type them into the comments. One of the questions I just had for you right now in the interim is, how did you come across this software, Mitaka?
Yeah, this was one of those things. Is one of our volunteers at the observatory mentioned it. He said that he was using it and that it's free. We had some other ones that just they didn't quite work as well as this. Like Google Earth doesn't do this. It's like it's just so easy to manipulate. And so it was as far as I can tell, it's a Japanese group of astronomers that decided to do this, and they just put it out on the web for free. The first editions were in Japanese only, and then they started making English versions. And so the best way to find it is just do a Google search for MITAKA, and it's called 4D2U. It will come up. I think it's usually the second or third thing down on Google. And yeah, it works. It does not work on Macs. It works only on PCs right now. They did have a Mac version, but it just didn't fly too well. So, but yeah, it is, as you're at home, oh my gosh, you can just like spend hours on this and fly around. And
But again, we wouldn't have your great narration to go with it. I mean, I
well,
feel like I'd be
sound
flying
effects.
blind. Yeah.
I mean, you know, this is what you get is you get the sound effects when you get an astronomer doing this. That helps, I think.
Well, great. Well, we have just two more questions I do want to toss out there. From Deborah, can you talk a little bit about star clusters and where did they come from?
Star clusters and where they come from. That's a good question. Let's see. Let me go back to. I'm going to try the share screen. It's always risky to go back to this. But I'm going to try it real quick. So star clusters. Let's go. Yeah, that's true. Let's go to that one. No, let's go to this one. Okay. So this is another program that I use a lot called Starry Night Pro. And it's this one costs, there it goes. There we go. You see a lovely field with really bad graphics of trees.
I see it.
Okay, good. So this is a program. This can show us what's up in the sky any time of day we want. So if I make it nighttime here, I'm going to make the sun go down and the stars will pop out. So here's the stars tonight. And one of the best star clusters that I like to look for is, well, let's go to that one. Let's go to the early one first. So it's one that you can't see very much. It's hard to see because it's lower in the sky, but it's right here. This is what's called the Seven Sisters star cluster. There we go. And this is the Seven Sisters. And so this is an open cluster of stars, meaning you can see the space in between the stars. So they call those open clusters. And they usually have a couple hundred stars in them. And this is the most famous one, the Seven Sisters, or the Pleiades. And they formed from one giant nebula, a big cloud of gas and dust that came together, gravity brought together, and formed these into stars that we see there. So this is kind of like where our sun came from, was from a nebula, and we were part of a group of stars too, not as many as this one, but we were in the very distant past. So that's a good example of an open cluster. The other kind of clusters we call are globular clusters, and the most famous one, we talked about Omega Centauri, that's one that you can see in the southern sky. The other more famous one, at least for us here farther up north, is in the constellation Hercules. And oh boy, this will be good. You guys can test out your imaginations, and I think you should see a constellation that's like Hercules. Let's see, where is he? He's thinking about it. Oh yeah, there he is. Yeah, that makes a lot of sense, doesn't it? Okay, well, whoever invented constellations, I don't know, that's kind of tough. But what we're looking at is right here. This is called a globular cluster. This is the Hercules cluster. Another great object to look at in a telescope. It looks just like that. This is a globular cluster, meaning it looks like a globe of light that's around here. And so this is a borderline galaxy. It's almost big enough to be a galaxy, but this is still within the Milky Way. And we're looking at hundreds of thousands, maybe even millions of stars. And how those formed is still not exactly understood completely. There's a lot of debate as to how old they are, how long they've been around, but definitely an interesting sight to see. So that's the Hercules cluster.
So one last question. This one's from Dana, and she just had to ask, since you are an astronomer, do you have a stance on astrology?
Oh boy, oh my gosh. Well, that's a touchy subject for me also.
You rattled us with Pluto. I thought this just, was
why not?
fitting to
Why
also
not?
end on.
I will. Yeah. So astrology and astronomy are often kind of used interchangeably. However, astrology, boy, we have a tough history between the two of us. And while astrologers like astronomers, like they think we're like in this together and we're working together, astronomers, we don't see that. In fact, if you ever want to offend an astronomer, call them an astrologer. It is one of the most offensive terms to us. And the reason why that is because it's, well, we're based on observations and scientific evidence and all that, and I still haven't been like convinced on astrology because I'm a Sagittarius, so of course I'm going to be skeptical of astrology. So I mean that's just how it is. That's how I'm built. So I just wish the tricky thing with astrology is that they don't actually watch the sky. I was surprised about that they're astrologers are very into their charts and their books and everything, but whenever I ask like, oh, did you see the constellation Gemini up in the sky? They're like, oh, I don't even know where that is. I mean, it's like I don't know. I guess I like looking at the stars. So I'm definitely firmly an astronomer because I like actually getting out there and seeing the stars. But yeah, I haven't quite warmed up to astrology yet. And I have given talks to astrology groups before and explained how they can make astrology better by really charting the stars and charting your paths. And I can make a chart for you very easily that's a lot more accurate than an astrologer chart too. But they still like me at the end. I don't know why, but they still do at the end. But it's just, yeah, if you're around astronomers, especially if you're at the Lowell Observatory, please call them astronomers. They will appreciate that a lot better.
I'm sure. We'll make sure to not make that mistake and burn any bridges with our Lowell friends.
Boy, how diplomatic was that? I don't know.
I was impressed. You've been such a trooper with us and our questions today. So for everyone, thank you guys again for joining live. This was so fantastic. And having Dean Regas with us from Cincinnati Observatory, all the way from Cincinnati, here on our page in Grand Canyon Flagstaff time. And just to reiterate again, so is that software Mitaka and then the other one, are those free that people could access on their own?
Yeah, so Mitaka, the one where we flew around the universe, that one's free. So yeah, you can do a search for MIT AKA on Google and it'll come up. But usually it's called 4D2U is what will come up. And then the program where I show in the clusters, that's called Starry Night, which does cost money, but there's a free version called Stellarium. So I'd highly recommend that. So stellarium.org is where you can download that for free and do everything with even better graphics on it too.
Great. So for everyone, Grand Canyon National Park is still closed, but us here at Grand Canyon Conservancy are going to continue to bring you digital opportunities just like this to stay connected and to learn some educational tidbits. And so this week, I hope you got your dark skies fixed. This was a fantastic week for International Dark Sky Week. Thanks again, Dean.
Sure, my pleasure. Thanks for having me. Thanks, everybody. Hope to see you all out there in the Grand Canyon soon.
Hopefully, yes. And so if you guys are still looking for some more dark sky fix, please feel free to check out our website, shop.grandcanyon.org. And we have a whole collection of dark sky themed merchandise, including some handheld guides and handouts to help you do some stargazing in your own backyard, as well as a very challenging dark sky puzzle, which we are still working on our version here at home. And then if you want to learn about what we're doing to protect Grand Canyon's dark skies, visit us at grandcanyon.org. Thank you guys again, and happy National Virtual Park Week. And International Dark Sky Week. Stay well and have a great day.